For today's lesson, we're going to be looking at matrix operations. So we have already looked at that a matrix is a way to organize data and organize numbers that we may have in a number set. This is done by looking at the numbers inside these brackets or parentheses, and you'll have various numbers in here. It may be a 2 by 2 matrix like this one where it has 2 rows and 2 columns up and down. All right, or it could be a 3 by 2, okay, or a 3 by 3. Okay, a matrix could be as big as we need it to be to organize the information that we have. But for these first examples, we're going to look at some smaller matrix operations that we have. And the 3 operations that we're going to look at is first addition, second scalar multiplication, and then subtraction. Okay, so let's look at our first example with some matrix addition. Okay, so for this, we're going to say that matrix A is going to be 3, 2, 1, and 5. All right, and matrix B is going to be 0, 2, -4, and -3. All right, so for matrix addition, we might be asked to do A plus B. So matrix A plus matrix B. So everything in matrix A plus everything in matrix B. And what that's going to do for us is it's going to give us another matrix that's going to have 2 columns and 2 rows. Okay, but the numbers that go in each of these spots have to do with the location of the numbers in each. So what we're going to do, since this is addition, we're going to add the row 1, column 1 piece with the row 1, column 1 piece here. So 3 plus 0 is just 3. Okay, then we're going to go and move to the second column in row 1. All right, and the second column in row 1 for matrix B. Okay, we're going to add those pieces together as well. 1 plus 2. Well, that's also 3. Okay, for our second row, all right, again, we're going to go back to this first column. Row 2, first column is a 2. All right, row 2, first column is a -4. So we have 2 plus -4, and that gives us a -2 in this space. And then lastly, we have this row 2, column 2. So we have 5 plus a -3, which is going to give us a +2. So the solution for this, for A plus B, matrix A plus matrix B, is going to be 3, -2, 3, 2. And we get this by adding the corresponding pieces with one another in the matrix. All right, let's look at another example for us. Let's look at this example. So let's say we have 5, 1, -2, and 0 plus this matrix. Let's say we have 4, 8, -1, and -4. Okay, so again, we're going to add the corresponding pieces here. So row 1, column 1 with row 1, column 1. So this is going to give us, in this first location, 5 plus 4 is going to be 9. Okay, we're going to move on to row 1, column 2. All right, we have -2 plus 8, which is going to give us a +6. All right, we have row 2, column 1. 1 plus a -1 is going to give us a 0. And then in the last space, 0 plus -4 is going to give us a negative 4. So this is the resulting matrix from the matrix addition. Okay, let's look at some matrix subtraction. So let's say we have this matrix here. Let's say we have 3, 1, 5, 2, minus 4, 0, 3, and 6. Okay. Well, we're looking at the same type of operation here, but this time we are subtracting in between the matrix. All right, so we're going to take 3 and we're going to subtract 4. So in the first location here, we have 3 minus 4, and 3 minus 4 gives us a negative 1. Okay, in our next spot, row 1, column 2, we have 5 minus 3. So we have a 5 minus 3 in this location, which is a positive 2. All right, for our second row, we have 1 minus 0. 1 minus 0 is just 1. And then in our last piece, row 2, column 2, we have 2 minus 6. So 2 minus 6 is going to give us a negative 4 here. All right, and so our resulting matrix, still a 2 by 2 matrix, all right, is negative 1, 2, 1, and negative 4. Okay, so this is how we would complete our subtraction. All right, let's look at this. Let's say that matrix A is equal to 3, 4, 1, and 9. And matrix B is equal to 7, 2, 6, and 5. All right. And let's make the 5, let's say negative 5 for that last matrix. And we want to calculate A minus B. So what is matrix A subtracted from matrix B? Well, that gives us 3, 1, 4, and 9 minus 7, 6, 2, negative 5. And we are going to complete this the same exact way. So I have 3 minus 7 is going to result in a negative 4. 3 minus 7 is negative 4. I have 1 minus 6, which is going to give us a negative 5. 4 minus 2 is going to give us a 2. And then in the last piece, we have 9 minus negative 5. And we know that when we have two negative numbers right there, 9 minus a negative 5, that we treat this just like we would addition. So this is going to turn into 9 plus 5. All right, I'm just going to put that over here on the side. It's in my thought category over here. All right, 9 plus 5, and 9 plus 5 is 14. So our resulting 2 by 2 matrix would be negative 4, negative 5, 2, and 14. Okay, so that is our addition and subtraction. Okay, let's look at what we do when we have multiplication in between. And we say that this is multiplying by a scalar number. A scalar number is just a number that's out front that you're going to multiply by. So in order to do this, we're going to go back and review the distributive property. So if we remember, the distributive property looks something like this. You may have had like an x minus 2 or something like that. And in order to distribute, you would multiply the 3 times everything in the parentheses. So this would be 3 times x, which is 3x, and 3 times negative 2, which is negative 6. And then that would be as far as you could go for that problem, since there are no other like terms. So for us, what we are going to do is now we are going to distribute this scalar. 3 is the scalar, and we're going to distribute that through a matrix. So for example, we might have a 2 on the outside of this matrix, and then a variety of numbers here. Let's do a 3-row matrix and 2-column matrix. So let's say negative 1, 1/2, 4, 5, negative 3, and 7. Okay. Well, what we're going to do to get the resulting matrix is we're going to multiply this 2 by every piece in the matrix. So we're going to have the exact same matrix, but everything's going to get multiplied by 2. So 2 times 4, 2 times 5, 2 times negative 3, 2 times 7. Okay? And this step right here is one that I usually skip when I'm doing this as far as writing all of this out. I just go through and I'll say, hey, 2 times negative 1. Well, that's going to give me a negative 2 in this first location of the matrix, row 1, column 1. And then I'll say 2 times 5 is 10. And then I'll work to the second row, 2 times 1/2. Well, 2 times 1/2, 2 times 1 is 2. 2 divided by 2 is just 1. 2 times negative 3 is negative 6. Okay, 2 times 4 is 8. 2 times 7 is 14. So this matrix here is the one that results from multiplying through with this scalar. This is the scalar product, the matrix that results from that. So very much like the distributive property, but now we're just distributing through that entire matrix. So after this lesson, we should be able to add matrices, we should be able to subtract matrices, and we should be able to multiply through with a scalar. So let's look at an additional example. All right, let's look at this example here. We're going to combine a couple of our rules and see if we can still solve this problem. So here is our challenge problem for the day. If you would like to press pause on this video and try to solve it to see if you want to challenge yourself. If not, you can just continue watching. But I would encourage you to pause it, try this out, and then see how you did with your solution. So let's say that matrix A is equal to 1, 2, 4, and negative 1. And matrix B is equal to 0, 3, negative 1, and 2. Okay, and what we are going to be asked to do is we want to find 2 times A, so 2A, plus B. So what this is asking us to do is it's asking us to multiply A by a scalar multiple of 2 and then add that to matrix B. So how will this look? This will look just like this. 2 on the outside of our brackets, all right, plus matrix B here. So you see, nothing has changed from matrix A. This is matrix A. It's the exact same here. This is matrix B. This is the exact same here. The only thing that has changed is we now have a 2 that's outside. So what we need to do is we need to multiply this scalar, all right, in to this matrix. And then we will add the resulting pieces from that. So let's do that first. All right, I'm going to go ahead and copy down matrix B. All right, so 2 times 1 is 2 for this first part of the matrix. 2 times 4 is 8. 2 times 2 is 4. And 2 times negative 1 is negative 2. Now that we have 2A completed, right here we have doubled matrix A. We're going to add it. All right, we're going to add this to matrix B. Okay, so 2 plus 0 is going to give us 2. 8 plus 3 is going to give us 11. 4 plus negative 1 is going to give us 3. And negative 2 plus 2 is going to give us 0. So this is our resulting matrix for this problem.